Hello everyone, my name is Ashok Jagapati. I would like to present my project Arduino based smart irrigation system using Internet of Things. Let me start with the introduction. So why do we need to use smart irrigation system when we have traditional irrigation model? The main objective of this project is it saves a lot of energy, like electrical energy, power, and manual labor work. And the most important thing is time. The user will be able to control and monitor his farms which are located somewhere else using the internet, using a laptop or a smartphone. The only thing the user needs is just a smartphone or a personal computer to monitor and control the farms, and to release the water and all. So how exactly, like what are the equipment and different apparatus we used in the project? I'll go through the slides. So here's a list of the equipment which we have used in our project. The temperature sensor, soil moisture sensor, flame sensor is an additional value to this project, and the driver circuit to drive the water pumps and to open the solenoid valves, and an Arduino Uno board, a near bus cloud software, and user interface components which we have already taken from near bus software again, and solar panels. Coming to the block diagram, I'll give you a brief functioning of the block diagram here. The temperature sensor LM35 is connected to Arduino board. The moisture sensor is connected to the Arduino board. pH sensor connected to the Arduino board, and the flame sensor. All the sensors provides only analog signals to the Arduino board. The Arduino board will be able to read only digital signals, so all the analog signals are in turn converted into digital signals, and it drives water pump and solenoid valves. So the functioning of temperature sensor is we in the programming we will mention or we will specify a certain temperature level. Whenever the temperature goes or reaches that particular temperature point, we program the Arduino board in such a way that the pumps or water pumps should be automatically activated. Same as with the moisture sensor. Whenever the moisture content of the soil goes below the specified level, the Arduino board again activates the water pump so that it reaches the required level of the moisture. And the pH sensor, the function of pH sensor is it detects the health of the soil, like there are various minerals in the soil, like potassium, nitrogen, carbon dioxide. All these parameters are read through pH sensor, so that the user will be able to know how healthy his soil is, and when and where to take the appropriate action can be decided by the user. The flame sensor, it's an additional, as I said, advantage to this project. So whenever there is an emergency fire accident in any of the farms, the user immediately will not be able to reach the farm, or he will not be able to send any rescuing emergency. So he just needs to turn on or trigger the solenoid valve and water pump, or even we can program the Arduino board. So whenever the flame sensor detects a flame or fire in that particular range, it automatically activates the driver circuit, and all the sprinklers or whatever the water pumps that are connected, it all gets activated so that we can suppress the flames. And on the top of the block diagram you will be able to see the solar panels. The purpose of the solar panel is to minimize the electrical current utilization. So we in this project we are using solar energy, and that is converted to the into electrical energy using the diodes and all. So here is a brief implementation of our project. So starting from the inputs like sensors, Once the sensor detects the signals, could be temperature level, it could be moisture level, it could be the pH factors, all the information is sent to the user. So every now and then user will be able to see by logging into the nearby software. At the same time, the Arduino board also sends a notification to the user. So when the moisture level goes below the specified level, in this case we have mentioned the moisture is less than 50, the notification is sent to the user. So that it all depends on the response. If the user says yes, the Arduino board triggers the solenoid valve and the water pumps. So that's how the sprinklers or drip, whatever it might be, it gets working in the farms. If the response is no, the system itself starts working, because we have already programmed the Arduino board. Accordingly, the system starts working and it maintains sufficient amount of moisture in the soil and the health status of the soil. Here is the circuit diagram and various components and the respective connections. So I'd like to show the video of the circuit diagram. Here is the circuit diagram. See, this is the temperature sensor. We could not able to locate all the equipment in this website. So what we able to get was a temperature sensor, a motor. So whenever the temperature reaches or goes high or low, so according to the program, the motor starts working. Same as with the temperature also. So we can connect all the inputs in similar fashion, like the moisture sensor and pH sensor and flame sensor. All the sensors are connected here. The analog input, you'll be able to see 5 inputs, right? We can connect to any pin here. So all the analog signals are converted into digital and we'll get the output from here. All these 13 pins starting from 0 to 13 are digital pins. So the motor is connected to the pin number 11 here. So this is all predefined, like it has been programmed and uploaded to the Arduino board. That's how it is functioning right now. So the software and user interface part, my team member Avinash would like to explain.
Thank you, Ashok. Hi, everybody. Hi, ma'am. Yeah. In my team, my role is software part. Okay. Let me briefly explain about what is NearBus. My colleague already explained about a little bit about NearBus, and let me start what is NearBus first. And in this project, we used a different cloud-based paradigm, that is NearBus. And you know what is NearBus exactly? The NearBus is a cloud connector that allows you to fully integrate in the cloud different MCU platforms like Arduino, OpenPS, etc. It's a very easy and transparent way. What exactly NearBus do? Instead of traditional concept of connect to remote devices to the cloud to control it, and the NearBus system maps the device into the cloud, doing a mirroring, like replication of a small part of microcontroller's memory into the cloud's memory. Under this paradigm, reading and writing its cloud's memory will have the same effect as you are reading and writing directly to the microcontroller's memory, simplifying the way in which the device is controlled. This mirroring process is between microcontroller's memory and cloud's memory is called the memory map process. So under the NearBus paradigm, as we can say that the remote devices more connected to the cloud will be mapped into the cloud. The main components of NearBus system has two main components exactly, as the remote device controller or near agent, and the cloud hub or near hub. These components communicates in a periodic way through a NearBus protocol. So we use a NearBus protocol in this project. And the main feature of this NearBus system is to allow us to control the remote agent from the cloud by a simple set of web API function is known as a Near API. Additionally, agent implementation, web the same way as a traditional microcontrollers. As you can see, right, what exactly I said before, this, we can make it our microcontroller as a cloud-based tool to help to, to connect a cloud near hub. And you can see the below diagram, right? Yeah, our physical device like motor, pumps, etc., these are all devices connected to the Arduino. And in Arduino, we can make it as a cloud paradigm, so it connects into a near hub, and our near hub is connected to the cloud app server by using REST API. Okay, let's go for next slide. Yeah, let's go for the UI functioning. In UI, you can see, right, what exactly you do for the to get the near bus functionality. First, you have to sign in, and you can see the screens, right? Sign in, go to the sign up screens, and to set up new user, really you can set your email, username, password. After the sign up, and you go for the next slides. You can see, right, to set up new device, you should configure the following fields, like device name, location, function, in pin, etc. These are all things. After that, download and install the near agent code library, Arduino library. You can see right in screens. After that, upload the Arduino Ethernet board into, restart the Arduino ID. You can see in next screens. Load the code, whatever the code you need for your project. And in my case, we use an soil moisture monitoring code. We upload into the Arduino ID. After that, you can set the agents configuration in your code, like you can see at screens agent password, agent ID, just like device ID is nothing but a MAC address of device. Like here, in this case, we use an Arduino's device MAC address to get connected with Arduino. After that, go for the next slide. Yeah, this is my final slide. As you know, configure the device. You can configure a device. You can configure the drop down menu device list and put the channel, and you can see the manage, control the soil moisture sensor and changing function up and down. You can see in all these functions. Yeah, let's go for the final project. Final in my project, and how our app is look like. Motor, motor and on and off, and get data. You can on the motor, you can off the motor, you can off through your mobile app. And if you want to know what is temperature, what is humidity, what is pH, exactly these functions, use the get data. You can click on get data. It's like you can get all this temperature, humidity, pH, etc. Fine. That's all about. And I'll show you my side exactly what it is. Let's go ahead. Yeah, here you can see my code to build for my site. Yeah, here we also use it for in JavaScript files. We use near bus API, and this is all about. And actually, in my code, I use an HTML, CSS, JavaScript, Bootstrap, AngularJS, React, and REST API to get the functionality exactly what we need. And let's go ahead for my site. Yeah, here you can see, right, about we are totally 4 members in this team, so we represent how our our site will be like, include how many members in my team, and what exactly about my project, and how many team members, and you can see all these things. And go for the explanation video. Here we can see about my project with a brief description about explanation. And go for the hardware specifications, how our circuit look like. And you can also see like required hardware, what hardware really need for my project. This is all you can see here. Just slide here and click this icon. You can see all these things. And let's go for mobile app. In mobile app, you can upgrade from my site to, you can control motor, all these things. Just power on. As of now it's not working because we didn't connect hardware right, that's why it's not working. But if you connect to the hardware and you configure your device, it's working properly, that's fine. And let's go at contact, where contact, you can drop your name and email and comment. We will get back to you within 24 hours. And you can also invest our idea. So, and we can see like our GPS based contact location. Yeah. Reminding and how is how will our project look like, and how can I get those functionalities. We can actually we can make a PDF file. You can see all these things from the step 1 to at the end of the project. You can see all these things, right? Thank you very much for understand. Thank you, and I'll get over to Ashok.
That's all about the project. So to finish with, the main advantage of the project is remote access and remote monitoring. The user will be able to control and monitor his farms from anywhere. He just needs to have a user interface like mobile or a personal computer, that's all. So it saves a lot of time, a lot of money, because there is no labor incurred in to run this project and all. The only thing is he just needs to set up the equipment there, that's all. It starts functioning whenever, according to the program, whenever he wants. He can also trigger the pumps by sending a signal from his mobile or a computer. So we can enhance this project in future by expanding the server, so that it can reach to every farmers, because there is a lot of scarcity of food which can be reduced using this thing, because very precisely we can measure the soil humidity, soil moisture and contents and all. So the wastage can be reduced, the utilization of water, utilization of electricity can be minimized. So the project is very economical. So thank you so much for your valuable time, and thank you so much for your patience.